Hey everyone, I'm Joel John, and welcome to my channel. Have you ever watched a movie like Star Wars or I, Robot and thought, man, it would be so cool to build something like that? Well, I'm here to tell you that this isn't just science fiction anymore. We're living in an age where building intelligent machines that can see, think, and interact with the world is a real job. Today we're diving headfirst into the incredible world of robotics engineering, the career that is literally building our future, one gear, one sensor, and one line of code at a time. It's one of the most exciting fields on the planet, and trust me, it's even cooler than you think. This isn't just about building clunky metal boxes on an assembly line anymore, though that's still a super important part of it. We're talking about surgical robots that can perform operations with superhuman precision, rovers exploring the dusty plains of Mars millions of miles away, and even friendly little bots that can vacuum your living room so you don't have to. The sheer variety is mind-boggling. From the deepest oceans to the furthest reaches of space, and even right inside our own homes. Robotics engineers are the architects of a new technological revolution. So, if you've ever been curious about what it takes to bring a robot to life, what these incredible machines are capable of, or how they're already changing every single aspect of our world, then you are in the right place. Stick around, because we're going to pull back the curtain on one of the most innovative and impactful careers out there. We'll look at what a robotics engineer actually does all day, the crazy places their creations end up, and why this field is, without a doubt, one of the coolest jobs you could ever have. Let's get into it. Alright, so let's start with the big question. What even is a robotics engineer? The simplest way to think about it is this. They are the masterminds, the creative geniuses, the problem solvers who design, build, test, and maintain robots. They are the ones who take an idea, like I wish I had something to help carry heavy equipment for soldiers, or it would be great if a machine could explore that dangerous volcano and turn it into a physical, functioning reality. It's like being an inventor, an artist, and a super nerd all rolled into one awesome package. They are the bridge between a digital command and a real-world action. But here's the thing that makes them so unique. They have to be a jack of all trades, or more accurately, a master of many. A robotics engineer isn't just a mechanical engineer who builds the body, or a software engineer who writes the code, or an electrical engineer who wires up the circuits. They have to be all of those things at once. They need to understand the physics of how a robot arm will move, the electronics to power its motors and sensors, and the computer science to give it a brain and tell it what to do. It's this crazy, beautiful mashup of different disciplines that makes the field so challenging, but also so incredibly rewarding. Think about the Mars rovers, Perseverance or Curiosity. A robotics engineer didn't just build a remote control car. They built a self-sufficient mobile science laboratory that had to survive a 7-month journey through space, a fiery descent through the Martian atmosphere, and then operate for years in an extreme environment with a 20-minute communication delay. They had to be experts in materials science, power systems, communication, computer vision, and so much more. They are the ultimate multidisciplinary superheroes of the engineering world, bringing machines to life to go where we can't and do what we can't. So we know they're multidisciplinary geniuses, but what do robotics engineers actually do all day? Does it look like Tony Stark's lab with holograms and wisecracking AI assistants? Well, sometimes it's not far off, but it usually starts at a computer. A huge part of the job is design, and for that they use something called CAD, which stands for Computer-Aided Design. This is basically super advanced three-dimensional modeling software where they can build every single part of the robot virtually. Every screw, every bracket, every gear, before a single piece of metal is ever cut. They can test how parts fit together, simulate stresses, and make sure the robot won't just fall apart the second it's turned on. Once the physical design is solid, it's time to give the robot its brain. This is where the programming comes in. Using languages like C++ for high-performance control, or Python for higher-level tasks and artificial intelligence, they write the code that tells the robot how to behave. This isn't just move forward, turn left. They program complex algorithms for things like computer vision, so a robot can identify objects, or path planning so it can navigate a cluttered room without bumping into everything. A big tool here is ROS, the Robot Operating System, which is like a standardized framework that helps all the different hardware and software components talk to each other without causing a digital traffic jam. But you can't just design and code a robot and call it a day. The real magic, and often the real frustration, happens during testing and integration. This is where they take the physical parts, the sensors, the motors, and the code, and try to make them all work together in harmony. It involves a lot of trial and error, debugging why a sensor isn't giving the right data, or why a motor is jittering. It's a hands-on process of tweaking, calibrating, and problem-solving until the robot moves and acts exactly as intended. And yes, it probably involves a significant amount of coffee to get through it all. Okay, so where does all this hard work end up? When you hear robot, you probably picture a giant arm in a car factory, welding doors onto a car frame. And you're not wrong. Manufacturing is still a massive user of robotics. These industrial robots are the unsung heroes of modern production, working 24/7 with incredible speed and precision to assemble everything from our smartphones to our airplanes. They do the heavy, repetitive, and dangerous jobs, which makes factories safer and more efficient for their human co-workers. But that's just the tip of the iceberg. Let's jump to a completely different world. Healthcare. Here, robotics engineers are creating machines that are revolutionizing medicine. You have surgical systems like the Da Vinci robot, which allows a surgeon to operate through tiny incisions with enhanced vision and dexterity, leading to less pain and faster recovery for patients. There are also robotic exoskeletons that help people with spinal cord injuries walk again, and pharmacy robots that automatically dispense medications, drastically reducing the chance of human error. It's technology that is directly saving and improving human lives. And the list just keeps going. In logistics, fleets of autonomous robots zip around massive Amazon and Alibaba warehouses, finding and moving products to get your packages to you faster. In agriculture, robotic tractors can plow fields and smart drones can monitor crop health, helping to feed a growing global population more sustainably. In space, as we've talked about, rovers explore other planets. In defense, robots are used for bomb disposal and surveillance, keeping soldiers out of harm's way. From the farm to the operating room to another planet, the work of robotics engineers is everywhere. Now let's bring it back from Mars and the factory floor, right into our own living rooms, because one of the fastest growing areas of robotics is right here at home. For decades, the idea of a home robot was pure Jetson-style fantasy. We imagined Rosie the robot maid cleaning the house, cooking dinner, and offering witty commentary. While we might not have a Rosie just yet, the truth is that domestic robots are no longer fiction. They are quietly and efficiently becoming a part of our daily lives, designed with one main goal: to make our lives easier, safer, and maybe even a little more fun. The whole point of home robotics is to automate the mundane, the boring, the chores that nobody really wants to do. Think about all the time you spend on repetitive tasks like cleaning floors, mowing the lawn, or cleaning the pool. Engineers are looking at these exact problems and saying, a machine can do that. By offloading these tasks to autonomous helpers, they're not just giving us a clean floor, they're giving us back our most valuable resource: time. Time to spend with family, on hobbies, or just relaxing instead of doing chores. But it's not just about convenience. Home robots are also making our homes safer and more accessible. Automated security robots can patrol our property, and smart systems can monitor for everything from intruders to fires. For the elderly or people with disabilities, companion and assistance robots can provide a crucial link to the outside world, remind them to take medication, or help with simple physical tasks. This isn't about replacing human connection, it's about providing a tool that enables greater independence and peace of mind for both the users and their loved ones. So, what does this growing army of domestic helpers actually look like? Let's meet the team. The most famous and successful member is undoubtedly the robotic vacuum cleaner, pioneered by iRobot's Roomba. These little puck-shaped robots are honestly a masterclass in robotics engineering. They use a combination of sensors, like infrared cliff sensors to avoid falling downstairs and bump sensors to navigate around furniture, along with clever mapping algorithms to systematically clean an entire floor level on their own. They even know how to go back to their charging dock when their battery is low. It's a simple task, executed brilliantly. Taking that same idea outdoors, we have robotic lawnmowers. These operate in a similar way, using a boundary wire you lay around the edge of your lawn to know where to mow and where to stop. They can crisscross your yard, keeping the grass perfectly trimmed without you ever having to break a sweat. Then you have pool cleaning robots that crawl along the bottom and sides of your pool, scrubbing away algae and debris. In every case, it's about identifying a dull, repetitive job and building a specialized autonomous machine to handle it perfectly. But it gets even more advanced. We're now seeing the rise of companion robots, designed for social interaction. Robots like Jibo or LEQ are designed to combat loneliness in the elderly, telling jokes, playing music, and facilitating video calls with family. There are also dedicated security robots, like the Ring Always Home Cam, which is essentially a small drone that can fly preset paths inside your house to check on things when you're away. And we are on the cusp of seeing true kitchen automation, with robotic arms like Molly that can be programmed to cook entire meals from scratch. The specialized home robot is here, and it's getting smarter every day. Now that we've seen robots in our homes and in huge industries, let's zoom out and create a quick field guide to the main species of robots you'll find out in the wild. First, you have the big ones we've met, the industrial robots. These are typically robotic arms, known as manipulators, bolted to the floor in factories. Their job is all about speed, strength, and precision for tasks like welding, painting, and assembly. Then you have their cousins, the service robots, which is a huge category for any robot that helps humans, typically outside of a manufacturing setting. This includes everything from our little Roomba friend to the delivery bots you might see on a college campus. Next up are the highly specialized species. Medical robots, like the Da Vinci system, are designed for extreme precision and delicacy to assist in surgery or other healthcare tasks. Exploration robots are the adventurers, built to be tough, resilient, and autonomous. This family includes the Mars rovers, deep-sea submersibles that explore ocean trenches, and drones that fly into the heart of hurricanes. They are our eyes and ears in places that are too dangerous or impossible for humans to go. These are the robots that push the boundaries of human knowledge. Finally, we have a few more distinct types. Military robots are designed for defense, reconnaissance, and dangerous tasks like bomb disposal. Domestic robots, as we just covered, are the ones designed to help us out around the house. And then there's the category that captures everyone's imagination, humanoid robots. Think of Boston Dynamics' Atlas or Honda's Asimo. The goal here is to build robots in our own image, which is incredibly difficult. They are designed to operate in human-centric environments, walk upstairs, open doors, and one day work alongside us as true partners. Each of these robot species presents a unique set of incredible engineering challenges. So, after all that, why is being a robotics engineer so unbelievably cool? I think the number one reason is that you are literally building the future. You're not just writing code that lives on a server or designing a bridge that just sits there. You are creating a physical thing that moves, thinks, and interacts with the world. You get to have an idea, design it on a computer, hold the parts in your hand, assemble it, and then watch it come to life. That moment when you flip the switch and your creation moves for the first time exactly as you planned, there is no feeling quite like it. It's a tangible, visible result of your creativity and hard work. Another reason is that it is impossible to be bored in this field. Technology is moving at a breakneck pace. The sensors, processors, and AI algorithms you're using today will be outdated in 2 years. This means you are constantly learning, constantly adapting, and constantly being challenged with new problems. One day, you might be figuring out the mechanical linkage for a robot's gripper, and the next, you could be implementing a neural network to help it recognize different types of fruit. It's a field that demands lifelong learning, which keeps your mind sharp and the work endlessly interesting. But I think the most rewarding part is the impact. The things you build have the potential to fundamentally change the world for the better. Whether you're designing a prosthetic that gives someone the ability to hold their child's hand, a rover that could discover signs of life on another planet, an agricultural bot that helps feed the world, or even just a simple robot that gives an elderly person a bit more independence, your work matters. You are a tech artist, a modern-day inventor, solving real-world problems and leaving a lasting legacy, one incredible robot at a time. And that's a wrap on our whirlwind tour of the world of robotics engineering. We've seen how these engineers are part mechanic, part coder, and part artist. We've looked at their incredible creations, from the factory floor to the surface of Mars and even your own living room. The key takeaway is this: robotics isn't some far-off future concept anymore. It's happening right now, and it's shaping every part of our lives. The potential is truly limitless, and we are only just scratching the surface of what these amazing machines will be able to do. But now, I want to hear from you. What part of this field gets you the most excited? Is there a specific type of robot, maybe surgical bots or humanoid robots, that you want me to do a deep dive on in a future video? Or are you maybe thinking, this sounds awesome, how do I actually become a robotics engineer? Let me know down in the comments, because your curiosity is what drives this channel. And I'd love to make a guide on the exact steps, subjects, and skills you need to get into this field. Remember, the people designing and building these machines are the tech artists and innovators of the 21st century. They are solving some of humanity's biggest challenges with creativity, intelligence, and a whole lot of persistence. They are changing the world one robot at a time. Thanks so much for watching. Don't forget to like and subscribe for more deep dives into awesome science and engineering, and I'll see you in the next one.